Every month, a city the size of New York will be built until 2060, increasing the distribution of crime and emergency events across an enlarging global urban area. FlyDrone offers customers a unique solution in monitoring crime and emergency through a UAV that can reach high speeds with maximised endurance for loitering.
We're a small design team that wanted to change the way emergency services can monitor ongoing events happening in urban environments. We wanted to focus on building a sustainable product that could be cheaply manufactured and fulfill key mission objectives for police, first responders and fire units. When we designed FlyDrone, we went through several iterations before arriving at a solution that proved optimal for flight.
The design process involved evaluating key customer requirements, technical capability and limitations that could be encountered in designing FlyDrone. Identifying constraints via design tools that would be imposed as a result of mission objectives involved an iterative process that continually re-evaluated aerodynamics, structural capability, propulsion and weight. This all fed into the physical design and testing of FlyDrone, which verified fidelity between our theoretical simulations and our physical products.
When it comes to designing any kind of product, it is always important to keep in mind the requirements. Our UAV main application is to chase moving objects as well as determine their main characteristics through machine learning. Our drone must first fit the provided coffin so that it can be transportable to the testing sites, but also the payload within our drone must be easily accessible. And we have clearly met this requirement by essentially having a 1.2 meters long UAV, but also a UAV that can be easily assembled and disassembled in matters of seconds. Given the application of our drone, it must also be highly maneuverable. To respond and to meet this requirement, we have a high thrust-to-weight ratio, but also we have equipped our drone with an engine capable of producing 14 newtons of thrust, allowing therefore our drone to fly at a top speed of 25 meters per second. Our choice of material definitely allowed us to have a very light aircraft. Its actual operating weight is about 1.15 kilograms. The drone shall also be able to transmit and record clear and accurate data. And that is why we equipped our drone with a Runcam split camera capable of recording high quality footage but also transmit the data wirelessly thanks to its Wi-Fi transmitter.
Due to being a small design team, in the early stages of development we focused on using Microsoft Excel to automate our design calculations. This allowed us to easily change variables at any point of design. It also allowed us to gain a planform view of what our aircraft was going to look like. After using the design tool, we focused on manufacture. During the early stages of manufacture, we initially started to use an expanded polystyrene foam and a wire cutter to get the general shape of our aerofoil. After testing, we realised that this was in fact quite heavy for our intended purpose, so we chose another design material. We also looked at using a laser cut, wing, rib and spar design, however this took a long time to manufacture and was quite difficult to do so. After both of these, we eventually decided upon using Depron as our material of choice, as it is in fact very light and easy to manufacture, and also quite cheap. We incorporated an iterative approach to designing our aircraft. We started with the initial values that we gained from our design tool, put them into practice, and then made alterations based on testing. During the second semester, improvements were made to both theoretical and practical aspects of our manufacturing process. Improvements to the theoretical aspect involved slightly altering the design tool that was used to ensure that the results gained are closer to how a real-life aircraft will perform. Improvements to the practical aspect involve things such as more accurate construction techniques. This allowed us to create an aircraft that better serves its purpose and fulfills system requirements.
Early on in the design process, we tested for flight stability and control authority, propulsion system for sufficient power and thrust. Later, we learnt about structural integrity. More tests followed. Structural tests to avoid flutter and withstand forces induced by maneuvers. CG and static locations were optimized through testing too. Testing minimized failure modes to ensure safe operations. Each test was a lesson learned and led to an improved design. On one instance, our wings collapsed in mid-air due to a weak spar. We then introduced a stronger spar. As we have tested regularly, inexpensive testing was essential. That is why we also chose Depron.
FlyDrone is a system that is capable of significantly reducing the response time of any emergency service across any urban city. Its high degree of maneuverability, coupled with its onboard technology, allow the accurate and reliable detection of moving objects. This, in turn, can be processed through machine learning to obtain the main properties of the bodies being chased. As such, crime rates can greatly be reduced and even lives can be saved.